Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, safety and concurrency. In high-frequency trading and quantitative finance, nanoseconds matter. Python, while excellent for prototyping and data analysis, often lacks the raw performance needed for production trading engines. We explore why rewriting my engine in Rust yielded significant gains in latency and reliability, impacting profitability directly. Python's global interpreter lock (GIL) hinders true parallelism, limiting concurrency. Memory management, while convenient, introduces garbage collection pauses that are unacceptable in low-latency environments. We needed finer-grained control and predictable execution times, critical for mitigating slippage and maximizing execution speed against liquidity depth. Rust offers near C++ performance with memory safety guarantees. Its ownership model and borrow checker eliminate entire classes of bugs common in C++, such as memory leaks and dangling pointers. This translates to fewer crashes and increased confidence in the engine's reliability, directly impacting our Sharpe ratio and risk of ruin calculations. Rust's fearless concurrency allows us to leverage multi-core processors effectively. The absence of data races and deadlocks simplifies the development of highly parallel trading strategies. We are now able to process market data and execute trades simultaneously, significantly reducing latency and improving fill rates. Rust's control over memory allocation eliminates the unpredictable pauses associated with garbage collection. We can use stack-based allocations and arenas to minimize allocations in the hot path. As noted in recent research comparing Rust and C++ trading engine performance, this results in more consistent and predictable latency. We integrated customized agentic loops within our Rust trading engine. These loops use private RAG, retrieval augmented generation, to continuously analyze market data, adapt trading strategies, and manage risk in real time. Rust's performance allows these agentic loops to operate with minimal overhead, resulting in a more responsive and adaptive trading system. This approach ensures the system learns and adapts to changing market conditions faster than traditional methods. Using a private RAG architecture ensures that sensitive market data and proprietary trading strategies remain secure. This prevents leakage of valuable information and protects our competitive edge. We use Rust's strong type system and memory safety to build robust and secure data pipelines for our RAG system. Rust's performance and reliability make it ideal for scaling our trading engine. We can deploy it on high-performance servers with confidence, knowing that it will handle high volumes of data and transactions without crashing. The use of WebAssembly (WASM) allows the system to be executed closer to the data, minimizing latency and improving trading efficiency. This provides a robust architecture that can handle the demands of real-time trading in any market environment. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.